Alright guys, the next thing I figure you're going to have some questions on are the expressions and operations where you need to factor and simplify and that kinds of stuff. Get common denominators sometimes and all of that. So this one really isn't too tough. You factor both of them. This is a pattern, this is a regular one. So you factor the top to x plus 2 and x minus 2. So you don't need that anymore. You factor the bottom to x plus 2 and x plus 2, and they're not pluses, they are minuses. Pardon me. Okay, so minuses because negative 2 and negative 2 multiply to 4 and add to negative 4. Okay, so, and then the nice thing about this is that now we can see that 2 of them will cancel out. So minus 2 and minus 2 will cancel out. So it's x plus 2 over x minus 2. So a lot of you guys were fine on that one. This one is a common denominator problem, remember guys, because it's adding. So whenever you're adding and subtracting common denominator, instead of making them both larger, remember 7 can turn into a 14x if you just multiply it by 2x. So you do 2x in the numerator and the denominator, that changes to 6x squared plus 5y, and now the common denominator is 14x. That changes into 14x. That is 14x, and so now if you notice, it is one of the answers. You can't put x and y together. All right, some other questions that we had on this page were, ooh, didn't want to do that. Let's see. I think the spot is about there. Let me double check. Yep, that works. All right, so the other questions that we had were here. It's multiplication, so you do not need a common denominator, but you do need to factor, and this has a GCF. It is 6. So think of this as 6 times a plus 2 instead. And now everything else is pretty squared away and we kind of always left those the way they were. So a plus 2 and a plus 2 cancel out. We've got a to the third over a to the first. So one of these cancels out with one of those and makes it a 2. So the entire denominator is gone. 6 times a squared. And if you notice, it is this first one right here. Okay? All right, over here, before you figure out what to do, write it out long ways. It's much easier to see. So I'll write this one out. This is a good marker for it. So x divided by x plus 7 divided by the fraction x minus 9 over x plus 7. Now it's easier to see. It's division, and almost all of you guys know that's keep, change, flip. So x over x plus 7 times x plus 7 over x minus 9. That works out well because those cancel. So that's why it's x over x minus 9. Okay? All right. So then some of the other problems that more people had questions on were ones where you have to do multiple things, where not only do you have to write it out, but you've got to get common denominators and you have to keep, change, flip. So this problem is probably one of the longest problems in this area that we're talking about. So write the numerator, 1 over x minus 4 over y. We want to deal with that. Then we're going to divide it by the denominator, 2 over x plus 5 over y. And at the very end, we will keep, change, flip. But first, we need to look at them separately. So this one, we need a common denominator, which is going to be x, y. So that means I need to multiply these two by y. So 1 times y changes to y. Multiplying by y. Okay? This one needs the x, so I multiply both of those by the x. That becomes minus 4x. And then xy is my denominator, so I already wrote it down. Okay, then we're going to divide it by, okay, again, this common denominator is going to be xy. That means these both need a y, so that's 2y. plus these both need an x, so that's 5x, and then they're both xy, which I already have. Now I've got a fraction divided by a fraction, so now we can keep, change, flip. So y minus 4x over xy times xy over 2y plus 5x. Nice thing when we do that, these two cancel out. It's y minus 4x over 2y plus 5x, okay? You have to take it through those different steps to get from the beginning to the end, okay? Adding and subtracting first, common denominators, then keep, change, flip, then you can eliminate, all right? This one's a lot easier than you think. You've got a plus b, 3 of them up here, 2 of them down here, 2 of them cancel, and then you'll just divide the 18 and the 2 both by 2. The next part of questions was these roots. Now, I don't think there were really questions on 1 and 2, but on the next page, I remember having some questions. So, remember, you can do a problem like this, actually, in your calculator. You can take it to the 3/4 power, use the caret in your calculator. But this one is one that I had some questions on. Remember, in order to subtract them, they have to match. So since we already have a 2x right here, that means we want this to become a 2x. So you ask yourself, what times 2x is that? 72. Well, that factor pair is 36x squared times 2x. This times this gives us that 72x to the third. Well, that's helpful because I can square root this part and it'll leave the 2x like we want. Okay, so the square root of 36 is 6, so I'll pull that out. The square root of x squared is x, so this is gone, that's left. So really what it looks like is, I'll put it over here, 6x times the square root of 2x, these came out, that is still in, minus 5x times the square root of 2x. And now it's a lot easier to put together. 6x minus 5x is just 1x, 2 root x. So that's why it would be F. All right, the other question that I heard was number 4. Okay, number 7 you could do in your calculator. Just be careful with it. You could also multiply your powers, and you'll see they will turn into a -1 over here when you distribute your powers. So that turns into a -1, that turns into a -1, and then it'll just flip the fraction. Okay. So looking at this one, in order to convert fractions into roots, the roots have to match. And what I was saying to a lot of students is, remember, roots of a tree are underneath the ground, so roots of our exponents are under the problem. They are the under part of our fraction, okay? So, in order for us to put this in the same root, they have to be the same number. So all we need to do is convert that a to the 1/2. We just need to change it to a denominator of 4. So 1/2 is the same thing as 2/4. Now that the roots match, now we know it's a 4th root. A, its power is 2, and B's power is 3. Okay, so that's all we have to do. Make them match, then it's easy to put them in the root. Okay, roots are underneath, so that's always what goes in there. All right. Okay, number 5 is very similar to the other one, except there's no variables. This needs to turn into a root 3, so you're going to square root the 4 out. Once you get that factor pair, then you'll put them together. Number 8 was definitely one I had questions on. So let me move this over. All right, number 8. Okay, I want to make sure I've got plenty of room for number 8, so I'll put it over here. Number 8. We do not have that one number. So what we have to do is we have to think of cubes. All right, and in order, you might have to sit back and write your cubes. 2 cubed is 8. So we're looking for an 8, 3 cubed is 27, or 27. 4 cubed is 64, or 64. 5 cubed is 125. So these are the numbers that we're looking to be factors in here. So the cube root is 16. Okay, well, which one of these goes into 16? Well, that is the 8. So this becomes, let me write it over here, the cube root of 8 times 2. 8 will cube root, 2 is its factor pair because we're looking for 16. Then we're adding 3 times the cube root of 54. Well, 27 goes into 54, so that's 27 times 2. Okay, we choose that because that's about the cube root in a second. Minus 2 times the cube root. Let me pick a color here. Cube root of 27 also goes into 81. Excuse me, it goes 3 times. Okay, so I picked these numbers because they are cube roots. And so what I do is I actually cube root it out. So I cube root that 8 and I get 2 cube root of 2. I cube root this 27, I pull it out as a 3. I multiply 3 times 3, so that's 9 cube root of 2. I cube root this 27, I bring it out, that's a 3. 3 times that 2 is 6 cube root of 3. Okay? So whenever you bring one out, you multiply it by whatever's in the front. Then I put the matching ones together. These two match. That's 11 cube root of 2 minus 6 cube root of 3. Since those don't match, that's as far as you can go. And that's why you are left with, with this one. 11 cube root of 2 minus 6 cube root of 3. So unfortunately, when you don't have the number that tells you to match, you have to still think of factor pairs, write down your cube roots, and then decide which one goes in. All right, let's see. What else might we have? Okay, factoring, you guys have been doing factoring for a really long time. It's one of the things we've been focusing on the most. But factoring, the patterns will not be on your formula sheet. So if that means you need to write down the patterns for factoring, 10, 20 times, especially the cube patterns, then write those down because you want to make sure you get those easy factoring problems down. Like this one's a pattern. Cube root this, square root that, you get 3. Square root that, you get 25. It's plus and minus, okay? This one's a pattern. Square root that, you get 4x. Square root that, you get 1. So one's plus, one's minus. So that's why you would choose that one. Okay, this is, this we would use our x into our box, and the corners would just be A and B. Okay, I didn't have much questions on that. Most people were fine. This is a pattern. Cube root that, it's 2x. Cube root that, and that's 1. Then you just put them into your patterns. But you have to know your patterns. Just remember, there's only one minus in the entire pattern. Okay, no matter whether it's plus or minus, there's only one minus. So since there's 2 minuses there, it's out. Since there's 2 minuses there, it's out. This one only has 1 minus, so it could be that one. And this one only has 1 minus. So you could eliminate those, and then you just have to be careful which one's the pattern. And this one's the pattern. It's the last one's never, because we squared it, it's never minus. So you just need to memorize those patterns. That's regular factoring. That's pretty much just the pattern some more. So I'm not too worried about factoring with you guys. Don't forget that a problem like this, we always look for GCF first, then you'll factor the rest. Remember, I bet they'll have ones where you have to choose the factors. It's not going to be multiple choice. So don't ever, ever, ever forget your GCF, okay? Always remember that. It's always what we did first. All right, this is just factoring. Even though it's got more words to it, it is still factoring. Everything else was I. We talked a lot about I in the calculator. Just put it in just like it looks. Remember, I on the calculator is right here. That's an I right there, so you say second the decimal point, and that I will come up as you work with it. I didn't really have much questions about that. You just plug it in, make sure when you have a problem, especially like this one, parentheses around the numerator, parentheses around the denominator. But I think you guys are getting pretty good with that. And then these other problems are very, very similar. Just like for the statistics, I suggested that you use the ones I've already gone through. Same thing here, GCF here, factor here, and then eliminate what you can. Over here, you need to find the perfect squares in each of those, square root that perfect square out, and then combine your terms. I don't think there were very many other questions other than those. This one was a lot like the other one. So write it out, get a common denominator, then keep, change, flip. All right, it's a lot like the other one on the other side of the page. All right, I cannot think of, I don't remember very many other people asking very many questions on the rest of this. So, hopefully that answers your questions. This would be factor out of GCF. This is a pattern. You can eliminate a bunch of things. So hopefully that is enough to get you through the rest of them. The answers, I already posted the answers, but I'll also maybe take pictures and post them again so that you can check yourself and make sure that when you go back, it'll match. So, good luck.